Hello and welcome back to part 2 of the complete road design project using Autodesk Civil 3D 2025. Kindly watch the previous video to refer to the introductory design steps discussed. In the last session, we started from scratch, importing point data, creating a surface, developing two alignments with offsets and connected alignments, and design profile for the vertical geometry with design checks for regulatory standards. We'll start by renaming the offsets and connected alignments for better clarity and continuing to more advanced aspects of our road design process. This is the left offset for road 1 alignment, and this other is the right offset. I can zoom to the top of the alignment, then hover over the alignment to view the station information. With the station starting here going down, you can select the alignment, drop at modify, then reverse the station direction from here if required. Road 1 alignment stationing starts from top going down as explained. This is why the left offset is on the right of the Road 1 alignment. Road 2 alignment stationing starts from this intersection. This makes the top offset to be at the left side and the bottom at the right side for Road 2 alignment. Proper naming streamlines the design process as you will see later on. I will select this curb return alignment, then go to Alignment Properties. In Information tab, we can edit the name to Left Curb Return, highlight and copy the name to clipboard, hit Apply, then OK. Select the other curb return, then go to Alignment Properties and edit the name to Right Curb Return. Ensure to set the type as curb return from here, then hit Apply. You can edit the connection parameters from the last tab for the curb return. I will proceed without criteria-based design and hit OK. This step is crucial for design clarity and workflows such as corridor modeling. Place the cursor above an alignment to view its properties. This is the left offset for Road 2 alignment. This is the Road 2 alignment which defines the offset's alignment. And to its right we have the right offset. Consistency in naming conventions ensures that alignments and profiles are easily recognizable. This minimizes confusion when working with complex networks involving multiple alignments and profiles. Road 1 left alignment will be used as a target for both width and elevation when designing this intersection manually, so kindly watch till the end for a comprehensive understanding of the workflow. We defined an intersection at the point where the two alignments meet. The intersection object contains the relevant details associated to the intersection. Select the intersection marker, then select Properties and go to Details to view the intersecting alignments, station and profile details. I will guide you through the complete process of designing this intersection manually with the corridors having different cross-sections. It is important to rename your alignments to match the profiles before modeling the road corridor. You can access all alignments in your drawing from the Toolspace palette. Expand alignments to view the categories. In centerline alignments, I have Road 1 alignment here. Expand it, then expand profiles to view its associated profiles. Right-click on the design profile. Then go to Properties and edit the name to correspond to the parent alignment name. I will rename to Road 1 Profile. Hit Apply, then OK. I will repeat this process to the other alignments in this design. I will expand Road 2 Profiles, then rename the design profile to match the associated centerline name. Hit Apply, then OK to proceed. This will help us when designing the corridor as we'll easily match the centerline alignment to its profile. We can proceed to renaming the offset alignments by dropping here to view the available alignments. I will fast forward this part as I edit the offset alignment names to my design-specific template. Offset alignments represents parallel alignments such as shoulders, curves or lens edges which are created from the center line. With the type as offset and name defined, I will hit apply, then OK. I will rename the other offset alignment names in this design according to the corresponding alignment and side. You can use the offset alignment tool to generate parallel alignments for rod lengths or shoulders by setting the specific offset distance. Verify that the offset dynamically responds to changes in the centerline alignment if required. After renaming the offsets, you can place the cursor above any alignment to view the name. Each offset alignment has the name template of alignment, then side offset. The curve return alignments name are OK as you can see. The next crucial step is to match the profile names for the offset alignments. From the toolspace palette, you can expand each alignment offset. Then expand profile to edit the profile name by right-clicking, then go to properties. I will rename to Rod 1 left profile. You can set the profile style by dropping here. Then select from the available styles for your profile view. Hit apply, then OK. I will fast forward again as I proceed to edit the other offset and curve return alignments profiles to match the parent alignment name. By linking names logically, any edits to profiles can propagate automatically in objects like corridors and sections. You can include different identifiers like main rod, offset or intersection in the naming conventions. This is a crucial step which simplifies the corridor target selection. By taking the time to edit and synchronize alignment and profile names, you are not just organizing your Civil 3D project. You are setting the stage for smoother collaboration, accurate designs, and professional quality outputs. We can discuss how to adjust the design profiles to satisfy the design checks defined in the previous video. We need a new check for the tangent grid which can be created from the toolspace palette, then settings tab. Go to profiles, then design checks, then line. The previous defined check is not suitable for use and we are going to be using a new expression for our grade check. I will share the new grade check expression in the download folder for this video in my Patreon page. This expression will take care of the grade limits for both positive and negative ranges. This expression ensures the tangent grade is within the range of -9 to -0.5% or 0.5 to 9%. Right-click on line, then select New. I will edit the name to grade check, then paste the text in expression. This expression has limits of -9% as the maximum negative grade and a maximum positive grade of +9%. Our minimum grade is 0.5% for our profile grade check. We can add this check to our design check sets from here. Right-click on Rod 1, then Edit. Select the subdivision tangent check. Then press this red icon to delete it. Select the new grade check, then Add. Hit Apply, then OK. Right-click on Rod 2, then Edit. Select the subdivision tangent check, then delete it from here. With type as line, I will add the new grade check. Hit Apply, then OK. Kindly subscribe if you are finding this tutorial helpful. This grade check will now be used at both profiles in our design. You can watch the previous video to learn how to utilize the design checks for alignments and profiles. We can now adjust our design profiles with the new grade check. I will select Rod 1 design profile, then drag this point up to somewhere here. The profile label updates dynamically and this grade is within our limits as defined in the grade check. At this vertical curve, I will place the cursor above the warning to view the violated design check, which is the minimum length of vertical curve. We'll come back to clear the error warning. Our minimum tangent grade was plus or minus 0.5%, and we have a warning because this tangent is below our minimum grade. We previously discussed how to superimpose Road 2 profile to Road 1. I will zoom to the start of Road 2 design profile. If I select the design profile, we can see that this point is dynamically locked to Road 1 alignment. This means that Road 2 design profile and Road 1 profile will have the same elevation at the intersection, even if we adjust Road 1 tangent up or down. I will select Road 1 profile, then adjust it using this grip by going down and snapping it somewhere here. 0.94 is within our grade check limits. In Road 2 profile, you can notice that the elevation of the starting station has adjusted as we changed Road 1 profile end. This grade is below our minimum grade, but before we adjust it, we can first modify Road 1 profile curve length to clear this error. You can adjust the curve length by using the point grips below the profile label. I will select this grip, then go right up to somewhere here and click. Extending the curve end will adjust the K and vertical curve length values in the profile label as seen. No error is at the curve, which means that the new curve length is above the minimum value provided in the design check set. Our tangents and curves for Road 1 profile have been defined without errors for all Road 1 profile check sets defined in the previous video. I would like to demonstrate what will happen if I vertically move Road 1 profile upwards. If I zoom to Road 2 starting station, we can note that the elevation is at 1628.605. I will zoom to Road 1 profile view, then use the move command to drag my profile up along the profile view border. I will select Road 1 profile, then hit M, then enter. I will pick from the endpoint, then move up and click to place. Select Move the best fit data with the profile. This has only adjusted the profile elevations without affecting the tangents and curve profile shapes for this Road 1 profile view. The starting elevation for Road 2 has automatically adjusted to the other intersection elevation, and this only affects the first tangent in this other profile view. The last tangent has maintained its grade as the two tangents are separated at the point of vertical intersection. I will select Road 2 profile, then move this PVI down to change both grades of the tangent to somewhere here. The first tangent now has a grade of minus 0.8% and this other minus 0.412% with a grade violation. I will select this endpoint, then drag it down to somewhere here. This tangent grade is now at minus 0.574, which is above our minimum grade value. We'll need to add a curve between the two tangents. It is recommended that the final design profile should have a balanced cut and fill ratio with the existing ground surface. The cut material can be utilized at the fill sections. I will select Road 2 design profile, then go to Geometry Editor. Drop at curve, then select Free Vertical Curve Circular. Select the first, then the next tangent. Specify a radius, then hit Enter. I will press Escape to exit the curve command. Select the curve, then use the endpoint to adjust the curve length. You can view the profile label values as you adjust the curve. I will lengthen this curve by extending this end outwards up to here. The K value decreases with the decrease in the vertical curve length. K value is the horizontal distance required for a 1% change in grade. If I set the curve length below the specified minimum value in the design check set, an error will be indicated at the curve. We can adjust the curve length from the Profile Layout Tools Parameters command. Select the command, then drop here and set to Entity Based. Click on Select Entity from here, then zoom and select the curve. We can adjust the curve radius or length from the profile layout parameters and view our design checks from below here. I will edit my length value to 90, then hit enter. The error message has been cleared at the profile curve, and that is how you can adjust the curve length using the profile layout parameters. A high K value indicates a less steep vertical curve. To reduce high K values while maintaining compliance, you can slightly increase the tangent grades before and after the curve. You can also shorten the vertical curve length to reduce the K value. I will select Row 2 Profile, then move the endpoint using the grip up to somewhere here. I will reduce the curve length and utilize the new tangent grade. Fill material will be required here, and it can be obtained from cut sections within the project route. The design profile should also follow the natural grade of the existing terrain for purposes such as drainage works. I can lower the curve length by selecting the curve. Then move this endpoint towards this side and click to place. The profile label parameters updates with change in the profile details. I can move the curve endpoint inwards to reduce the curve length. If the grades before and after the vertical curve are close to flat, the resulting curve will need a higher K value to provide the required transitional length. The K value is directly linked to stopping or passing site distances requirements. The K value decreases with a decrease in curve length. Carefully optimize your vertical geometry to create a design that's both functional and economical. Always validate your design profiles to ensure compliance with standards and eliminate errors before moving to the next phase. We can briefly switch to the software that you can use to edit your country's road manual parameters for use in Civil 3D criteria-based design tables. We can explore how to edit the default ASHTO design criteria file using Oxygen XML Editor. Open Corridor Design Standards. Then select Imperial or Metric folder. We have the default Civil 3D design criteria files that comes when you install the software. I will select the 2011 version at the top, then hit Open. The editor opens the source code format for the default criteria file. Click on Grid from here to change the screen layout. You can expand from this icon to view more grids. The default units is metric because we opened from the metric folder. We can expand alignments to view the tables. Expand the minimum radius tables, then expand again to view the rows. You can now open each super elevation table, then edit from here to match your design manual values for the design of the horizontal alignment. Double-click on a cell to edit the value and make sure to set both speed and radius values as given in your manual. Edit each super elevation rate tables from the minimum radius tables. These values are used in Civil 3D when designing the alignment with the criteria file. You can edit the super elevation attainment method formula from here for alignments with curves. For the formula descriptions, you can expand here to define both the crown and planar roadway transition styles formula as expressed in your country's road manual. Proceed to open the tables that need to be edited, then carefully edit what needs to be edited. You can save time or spare a day to complete editing your criteria file to your standards. I will expand profiles, then expand the minimum K tables, then expand again. These are the provided tables in the criteria file for profiles. The file contains tables for the SSD, PSD, and HSD for the minimum K values. As you expand each table as seen, you can edit both the speed and K values from the cells to match your manual. These are the default ASHTO values, and in the previous video, I had already edited and saved my custom file. Edit each table, if using a different manual from Ashto, and you will have your own custom criteria file that matches your region code. You can send me an email if you need the download link for this software, or browse for it from the provided links if you have the website link. Kindly subscribe if you're watching this channel for the first time, and thank you if you have subscribed to the channel. Let's proceed with the road design in the next video as we discuss the assembly creation for our 2 corridors. That's it for this video. See you in the next.